Good afternoon, children. This is Anman sir here. In the previous class, you have studied algebraic expressions, constants, variables, and their addition, subtraction, multiplication, and division in your earlier classes. You also have studied how to factorize some algebraic expressions. You may recall the algebraic identities a plus b whole square. So the factors of a plus b whole square is a square plus b square plus 2ab, and the factors of a minus b whole square is a square minus 2ab plus b square, and the factors of a square minus b square are a plus b into a minus b, and so on. Right? So, and also see, what do you mean by algebraic expression? Right? So an algebraic, the combination of variables and constants together called as algebraic expression. Right? So after that, you know that polynomials, right? A polynomial is an algebraic expression in which contains only the variables with non-negative integral multiples, and the types of polynomials is, yes, a polynomial of one term is called a monomial. A polynomial of two terms is called a binomial. A polynomial of three terms is called a trinomial. Right? And also a polynomial of degree 1 is called a linear polynomial. A polynomial of degree 2 is called a quadratic polynomial. A polynomial of degree 3 is called a cubic polynomial. Right? So every linear polynomial in one variable has a unique zero. A non-zero constant polynomial has no zero, and every real number is a zero of the zero polynomial. Right? And also you know that the degree of the constant polynomial is 0. The degree of the constant polynomial is 0. But the degree of the zero polynomial is not defined. So the degree of the zero polynomial is not defined. Right? Polynomial of degrees 1 is called as a linear polynomial. A polynomial of degree is 2 is known as a quadratic polynomial, and a polynomial of degree is 3, then it is cubic polynomials respectively. Right? A quadratic polynomial is in the form of ax square plus bx plus c, where a is not equals to 0 for all abc belongs to real numbers. Right? So a quadratic polynomial can have at least 2 zeros, and a cubic polynomial can have at least 3 zeros. Right? So these are the types of polynomial. So you have studied different types of polynomials. So one type was the quadratic polynomial of the form ax square plus bx plus c, where a is not equals to 0. When we equate this polynomial to 0, we get quadratic equation. Right? So quadratic polynomial of the form ax square plus bx plus c, where a is not equals to 0, when we equate this polynomial to 0, we get a quadratic equation. Right? So quadratic equations comes of when we deal with the many real life situations. Okay? So the word quadratic, which is derived from a Greek word quadrate, which means a square. So a quadratic equation in which the variable ax is an equation of the form ax square plus bx plus C is equals to 0, where A, B, C are real numbers and where A is not equals to 0, right? A quadratic equation in the variable x is an equation of the form ax square plus bx plus c equals 0, where a, b, c are real numbers and a is not equals to 0. For example, 2x square plus x minus 300 is equals to 0 is a quadratic equation. Similarly, 2x square minus 3x plus 1 is equals to 0. So 4 minus 3x square plus 2 is equals to 0, and 1 minus x square plus 300 which is equals to 0 are also the examples of quadratic equations, right? Okay. So the standard form of a quadratic equation is ax square plus bx plus c equals 0, where a is not equals to 0 for all a, b, c belongs to a real number. So this is known as standard form of quadratic equation, right? So the standard form of quadratic equation is ax square plus bx plus c equals 0. Here the coefficient of x square is a and b is the coefficient of x and c is the constant, right? So in this chapter you will study quadratic equation and various ways of finding their roots. You will also see some applications of quadratic equation in daily life situations, right? A quadratic equation in the variable x is an equation of the form ax square plus bx plus c equals 0, where a is not equals to 0 for all a, b, c belongs to real numbers, right? So the standard form of quadratic equation is ax square plus bx plus c equals 0, where a is not equals to 0 for all a, b, c belongs to real numbers. And so that a quadratic equation has two types. So one is adifacted quadratic equation and another one is pure quadratic equation. So the standard form of quadratic equation ax square plus bx plus c equals 0 is also known as adifacted quadratic equation. Adifacted quadratic equation is in the form of ax square plus b equals bx plus c equals 0, right? So it is ax square plus bx plus c equals 0, where a is not equals to 0 for all a, b, c belongs to real numbers, right? There is no difference between quadratic equation and adifacted quadratic equation, both are same only. Next we have pure quadratic equation. So in this pure quadratic equation, the b term does not contains, right? So the general form of a pure quadratic equation is ax square plus c is equals to 0, where b is equals to 0 and a is not equals to 0. Is it clear to all? So the general form of pure quadratic equation is ax square plus c equals 0, and the general form of adifacted quadratic equation is ax square plus bx plus c equals 0, where a is not equals to 0 for all a, b, c belongs to real numbers. Okay. The zeros of the quadratic equation ax square plus bx plus c and the roots of the quadratic equations ax square plus bx plus c is equals to 0 are the same. So there is no difference between zeros of the quadratic equation and roots of the quadratic equation, right? So quadratic equation has only two roots, right? A quadratic equation has at most two roots. Is it clear to all? Okay. Then come to the sums. So solution of a quadratic equation by factorization. Solution of a quadratic equation by factorization. So it carries 2 mark and one MCQ question for this in your annual examination. Okay. So let me start the question. Find the roots of the quadratic equation